All right, now we are looking at 8.2, just continuing on the next page. I can multiply and divide rational expressions by factoring the numerator and denominator and simplifying common factors. So most of multiplying and dividing rational expressions is the same as our simplifying. Okay, so we should be getting more practice here. So what we are going to do in order to multiply the rational expressions, in order to multiply, you have to factor all expressions, so all numerators, all denominators, multiply the numerators, and multiply the denominators. No distributing ever really for what we're gonna do. Okay. And then simplify. Okay. So like before, I'm gonna break it down into with real numbers first. Sorry, my throat is going. Before we get into expressions. So like 2 over 9 times 1 over 4. The first thing I have to do is factor all expressions. So this 2, there's nothing that divides into 2. 9 can be 3 times 3. And then I have times 1, and 4 can be 2 times 2. So then I have 2 times 1 over 3 times 3 times 2 times 2. So basically what I did is I wrote as one fraction, I multiplied my numerators, and I multiplied all the factors in my denominators. Alright, so you just go straight across here. Then I'm going to cancel out common factors. I have a 2 in both the numerator and the denominator. So now I have 1 over 3 times 3 times 2, which is 1 over, well, 3 times 3 is 9, times 2 is 18. Okay, so this is probably a little more complicated than you might make it, right? There's not really any point to break up this 3 and that 3. And that's easy to see with numbers, right? But it might not be as easy to see when we have expressions. Same thing with B. I'm going to do the same type of thing. 5 is just 5. 12, I think I can just break it up into 3 and 4. We'll see if I need to break that 4 into 2s, right? 16 is 4 times 4, and 15 is 3 times 5. Okay, so this type of trick that we're doing here, this is really how you multiply fractions and where all this multiplying comes from. And it makes it easier to multiply these big numbers and simplify them. Okay, so again, I'm going to write everything as 1, 5 times 4 times 4 over 3 times 4 times 3 times 5. Which equals, all I have on top is a 4 and a 3 times 3, right? And if I really wanted to say, I could say that's 4/9. Okay? So getting these factors and canceling things out at the beginning before I multiply everything together makes our basic fraction multiplication easier as well. Okay. All right, now let's look at some with expressions, okay? No GCF, right, an x plus 3, and it's not a quadratic, can't do anything. And that's going to be true of all of these. These are all just basic linear factors. So all I'm going to do is I'm going to write them as one fraction. I have x plus 3 times x plus 8 over x plus, that's not an x plus 8 times x minus 5. I do have a common factor. My common factor is x plus 8. All I'm left with is x plus 3 over x minus 5. So nothing different there, okay? So like I said, a lot of our multiplication is the same as our simplifying. Looking at D, I have x minus 3 over x plus 2. Again, both of those are just basic. Here I have x squared plus 5x plus 6. That is a quadratic. I have to factor it. Let's do it over on the side. I'm adding to 5, multiplying to 6. My two things that add to 5 and multiply to 6 are 2 and 3. So that's x plus 2, x plus 3. Okay. So that came from here. This is also a quadratic. This is difference of squares. So I'm going to take the square root, and we still get two things, the subtraction and the addition. Writing everything together, I have x minus 3 times, let's put in parentheses, x plus 2 times x plus 3 over x plus 2, x plus 3, x minus 3. My x plus 3's. Everything cancels out. So what happens when everything cancels out? It's the same as 1 over 1, which equals 1. Okay? Again, when something cancels out, it leaves behind a 1, not a 0. Okay? You can't divide and get 0. All right. Two more. We're going to up our difficulty level with our factoring a little bit. So I have 4x minus 2x squared. Doing my factoring on the side. This just has a greatest common factor. It has a common factor of 2. They also both have an x in them. So I'm going to take 2x out of both of these. The 2x, remember, goes on the side. 4x divided by 2x is 2. Negative 2x squared divided by 2x is negative, well, 2 times divided by 2 is 1x, or just minus x. So it's 2 minus x. Okay. Remember, we do not have to put this 1 here. Our other one, x squared minus 5x plus 6. We're multiplying to we're adding to negative 5, multiplying to positive 6. A lot of people want to say like 6 and negative 1 or negative 6 and 1, but that doesn't work. It is actually negative 2 and positive 3. Then we have this one here. I don't need a parentheses, sorry, ignore that. So we're adding to -4, multiplying to 3. And we get -3 and -1. So we have x minus 3, x minus 1. Okay. And then this is just one factor. It doesn't really do anything, right? It's just 2x. So writing down all my factors, I have 2x times 2 minus x. And then also in my numerator, I have this green part, x minus 3, x minus 1. In my denominator, I have x minus 2, x plus 3, this blue part, and also this leftover 2x. Canceling out some factors, I see a 2 and a 2, an x and an x. And that's it right now. Wait, this should be a minus 3. Sorry. Didn't I say minus 3? Minus 3. So that's my other, I thought those canceled. Okay. So now I have 2 minus x, x minus 1. The last thing I want to pay close attention to is these are the same, just opposite. So I'm going to take out a negative. So I'm going to take out that -1. Well, if I take out, right, and they flip-flop, because if I take out a negative from negative x, I'm left with positive x. And if I take out a negative from positive 2, I'm left with negative 2. So I'm left with -1 times x minus 1. Right, we kind of looked at that trick in our last notes that we can take out a negative there. Okay. All right, more factoring. Looking at our next problem, same thing. Anything that can factor, I'm going to factor it. So I have 6a squared minus 7a plus 2. This does not have a greatest common factor. So I have to add to -7 and multiply to 12. That's -3 and -4. Divide by 6. That's -1/2 and -2/3. So I have 2x minus 1 and 3x minus 2. A squared plus a. Again, looking for a GCF. Well, I can see an a in both of them. So I'm going to start by taking out an a. That a has to go on the outside. A squared divided by a is just a. And then a divided by a is just 1. One thing I just noticed is I changed my a's to x's. Which is a fine thing to do. You just have to know that the variables are... It's not going to bother me too much if the variables change. Just know that if you have an a in one and the x in the other, they're probably both supposed to be the same variable. Oh, that's scary. And then I have to, this I can't factor. It's just a 5a. Can't do anything with it. So I'm going to factor this 3a squared. Again, these don't have a GCF. I do have to add to 1 and then multiply to 3 times -2, which is -6. That's 3 and -2. I'm going to divide by that 3. Okay. So that's a plus 1 and 3a minus 2. Okay, writing all of my numerators. My numerators are red and blue. So I have 2a minus 1, 3a minus 2, and then I have an a. My denominators, I have this 5a, and then the green, which is a plus 1. Going through and canceling, I have an a plus 1 here. I have a 3a minus 2, and then I have this a and this a. The a's do cancel out. This is 5 times a. That is a factor. Those aren't connected. Okay? And I'm left with just 2a minus 1. And I don't need a denominator, right? If I didn't have a numerator, I'd have to put a 1. But we don't need a denominator. All right. Looking at our next section, to divide. Once we've practiced multiplying a lot, dividing is super easy. In order to divide, all you do is multiply by the reciprocal. If I could spell. And a reciprocal, remember, is just a flipped fraction. Okay? So instead of dividing, I'm going to change it to a multiplying symbol, and I'm going to flip just my second fraction. Okay, you don't flip both fractions. That wouldn't really change much. You flip just your second fraction. So we're going to have 7x squared minus 7x over x squared plus 2x minus 3 times, I'm going to flip this, so this, I'm going to have x squared minus 7x minus 8 over x plus 1. Now do the same exact thing. Factor 7x squared minus 7x. I can take a 7 and an x out of both of these. I'm left with 7x times x minus 1. X squared plus 2x minus 3. No GCF, so I'm going to add to 2. Multiply to negative 3. That's 3 and negative 1. So I have x plus 3, x minus 1. Here I have x squared minus 7x minus 8. I don't know why I put a fraction bar there. I'm going to multiply to negative 7 and negative 8. Or sorry, add to negative 7, multiply to negative 8. That's negative 8 times 1. X minus 8, x plus 1. This x plus 1 can't do anything. It's just how it is, right? So I have my 7x times x minus 1. And also in my numerators, I have x minus 8 times x plus 1. Then in my denominators, we have x plus 3 times x minus 1. And then my leftover x plus 1. And canceling out, my x plus 1s go away. And my x minus 1s go away. I am left with 7x times x minus 8 over x plus 3. And we'll just leave it like that. Okay, so you do not have to distribute back in or anything. Last one, again, you flip this one and only the second one. So we have 2x plus 6 over x squared plus x minus 2 times x squared plus 3x plus 2 over x plus 3. Factor 2x plus 6, because it does have a GCF. That's 2 times x plus 3. Factor x squared plus x minus 2, because it's quadratic. Add to 1, negative 2. That's 2 and negative 1. X plus 2, x minus 1. I have x squared plus 3x plus 2. Factor, I'm going to add to 3, multiply to 2. That's positive 2 and positive 1. X plus 2, x plus 1. Whew. Writing my numerators, we have the red and the green, so I have 2 and x plus 3. And then from the green, I have x plus 2 and x plus 1. From the blue, I have x plus 2 and x minus 1. And then I have my one that can't factor, just that x plus 3. Canceling x plus 3's, x plus 2's. This is x plus 1, this is x minus 1. While they are close, they cannot do anything. So you have 2 times x plus 1 over x minus 1. That is it. I'll see you guys tomorrow.